And to start our show off, we always like to go to that crazy little thing called Problem of the Day. So let's see what's happening. While we're doing that, if you'll give us a call, all right? Let's see. We have the base and altitude of a triangle that are in a 3:2 ratio. If the area is 48 square feet, that's area, by the way, in square feet, find the actual length of both base and altitude. All right, so let's take a look at that one. It's got a lot of words going on. Let's take a look at it here. I've kind of condensed it just a little bit. The base and altitude of a triangle are 3:2 ratio. Now, we're talking about the base and the altitude that come together somehow making a perpendicular, all right? They're coming together as a right angle, because those are the parts that you have to use to be able to compute that area. So let's take a look at it. We're going to use that formula for a triangle, 1/2 base times the height. By the way, Pollyanna Harris, hey, already submitted an answer, and I'm pretty sure she was right on it on Facebook, all right? Some others of you may have submitted since I last looked later this day. Hey, if you haven't, but quick right now, better do it fast, all right? Now, this is what I call a fusion problem, because it's a fusion of algebra, geometry, and really just some good old arithmetic. And this is not one of those that just jumps right out at you and say, the answer is ta-da-da. You're going to have to work out a little bit. We're going to use the formula, which is basically, you think of it just like arithmetic. But unfortunately, the base is not 3, nor is the height 2, all right? Or the altitude, as sometimes we like to call the height. So what do? You say, what do we do, Ernie? Because 3 times 2 gives us 6, and half of 6 is not 48, that's for sure, all right? So we've got to adjust this. Ratio, that 3:2 is important. It is important. We're going to transform that to 3 times something, don't know what it is, we'll call it x, and 2 times something, don't know what it is, but it's got to be the same thing. I've got to multiply that 3 by the same number. Maybe it's 8, maybe it's 10, but I've got to do the same thing with 2. So I could experiment and try a bunch of numbers, and I don't even, that could eventually work. But let's do it algebraically. Make it work pretty straightforward, all right? We do know something. We do know the area. So in the formula, let's put in some things that we do know. We've got a 48 popping in for big A. We have 1/2 of, I believe we're going to have 3x since we called our base 3x. Since it says 3:2, that means the base is going to get the 3 times x. And then we're going to multiply that by 2x, all right? Now, this is going to be really pretty straightforward and simple as long as you don't make any careless mistakes. You say, Ernie, how can we make careless mistakes? We watch Mathline, right? Well, let's see. Let's see what we're going to do here. First things first, 48, nothing happening. 1/2 right now, I'm not going to let anything happen to it. All right, I'm going to leave it alone. But what I do want to do, I want to jump over there and do a little associative property moment here. I want to take 3x times 2x first, and we'll come back and hit 1/2 on it. And I'm going to say 3x times 2x, which gives me, so you're going, 6x. Not quite. It's a 6. By the way, don't put a 5 down there. I have students that will do that. It's going to be at 1/2 of 6, but that x times x, my friends, gives us x squared. And that's what makes this problem a little bit more interesting, all right? Well, we're going to go ahead and take half of 6x squared, all right? So we got 48 equaling, by the way, we can't take half of the x squared part, but we certainly can take half of 6. So we're going to do the 3 and let the x squared come along for the ride, all right? Now, let's do a quick division, because 3 times x squared, we want x by itself. We've got a couple of steps to do before we get there. So first of all, we've got to divide this 3 out. We'll divide 3 into both sides. Division property of equality coming up your way here. And that gives us x squared because those 3's say goodbye. And 3 into 48 goes evenly. I'm glad it does. Gives us 16. Now, I'm going to slide over here. We've got x squared equaling to 16. How do we get rid of a square? X squared, we are going to want to get rid of that squared part. We want to keep x, all right? But we're going to square root both sides. And that's going to give us x equals, so square root of 16, it's going to be 6. No, square root of 16 is going to be what? 4. There you go. All right. So some of you are going, what? Wake us up, all right? And it's going to be positive because we're talking about bases and altitudes. Now you say, is that the answer? Not quite, because we are coming back to find the actual lengths. Not what x equals, but what is 3x? What is 2x? So we're going to put the 4 in there. It's going to give us 12, because that's what 3 times 4 is, right? And we're going to put the 4 in here, and it's going to be 2 times 4, which is going to give us 8. And there are our 2 dimensions. That will be the base. That will be our altitude. And some of you are going like, but Ernie, 12 times 8 equals 96. Yes, it does. But what do you do with a triangle? You got to take half. So we're going to say 12 times 8, 96, but half of that would be 48. You could also have said, hey, half of 12 is 6. 6 times 8 is 48. Or you could do the other way. Half of 8 is 4. 4 times 12, 48. It does come back. That's what I want to make sure you understand. This is easy to check. Make sure it makes sense in your problem. If I'd said 6 a minute ago, y'all would be going, huh? And Pollyanna's out there going, oh my goodness, I didn't do it right. She did. She nailed it around the head. I'm pretty sure she had 12 and 8 for her answers. And that's the fun of it, okay? Hey, folks, thank you. There's our problem of the day.